All right. Here of seem like it. Turn it up here. Maybe that's hopefully a little better on the sound. I'm guessing it started out a little quiet. If anybody is already on one of the streams, let me know if the sound is good at this point. I'm thinking it is. I see the bar a little bit better bouncing in OBS, so I think we're good. And I do need to shuffle a few windows around here. Let's get the chat back. YouTube is good. Thanks, Dexter. I appreciate that. And by the way, I guess I don't think I have ever asked before. Do you have a preferred name? Like, do you prefer to go by Dexter, or I think Randall, if I recall correctly, is on your GitHub, or it doesn't matter to you either way? Always should try to remember to ask folks that. And so, okay, I need to get the camera going. Let's do that real quick as well, and then we'll do the introduction browser, so it's very blurry, full screen. I'm gonna pop this over. And let's get some focus, and let's do the light, like the light better, there we go. And focus a little bit in, there we are. Yeah, that's looking better. All right, I'll hide that. Randall at work. Ah, I see, all right. Okay, so let's do a quick introduction for folks if you're new or if you're watching this video in the future and you've never seen anything before. Dexter here. Okay, I'll try to keep that in mind and go with Dexter since you're here, and this is where I'm most used to interacting with you. So for folks that might be new, my name is Tim. I go by foamyguy online on Discord and GitHub. In this stream, we'll be looking at CircuitPython stuff. If you don't know anything about CircuitPython, this is a version of Python that runs on these tiny computers, such as this Raspberry Pi Pico right here. This is called a microcontroller. They come in all different shapes and sizes. This one happens to be nice because it is really, really cheap. It's like $4 or $5 if memory serves for one of these, but it's quite capable as far as microcontrollers go. It's got a lot of I/O pins. It's got a relatively fast processing power with its CPU. It's got a good bit of RAM and everything, so it's a pretty nice little powerful microcontroller. And CircuitPython is a version of Python that runs on these devices, and it allows you to just save your code as a text file right on the drive. So this one is not plugged in yet. We'll plug it in, and then what we'll see is it will pop up a drive, just like a thumb drive, a USB thumb drive or anything like that. And we'll be able to save our files right on that drive. And as soon as we save the file, it will notice that it changed. We just edit this CodePy file. The device will notice that it changed, and it will run the new version of it. So the iteration loop for writing software is really, really quick, and you can achieve a lot of different things with the microcontrollers. Obviously, this one has a bunch of different pins, so you can connect up all kinds of different peripherals like displays and sensors and lights and buttons and knobs and speakers and pretty much any kind of little electronic widget that you can imagine. Most likely you can connect it up with these microcontrollers, and then once it's connected up, you'll be able to use that CircuitPython code to control what it's doing. So scoot this over, maybe get the glare a little bit better there. If you're interested in the CircuitPython project and you want to get involved, there's a couple of ways you can. The easiest is definitely just join us over on the Discord. That chat that I have pulled up in the stream right there is the Adafruit Discord in the live broadcast chat room. There's lots of different rooms, or I think maybe they call them channels. I'm not sure the right terminology, but there's a couple of different subdivisions of that Adafruit Discord. The live broadcast chat is the one that gets used during live streams, such as this one. and there's several others like CircuitPython development and help with CircuitPython, and a plethora of others as well. So if you do want to get involved, you can find most of the folks involved in the community do pop into the Discord from time to time, or are pretty active over there. So definitely encourage you to join us. Yes, as Dexter notes, we're definitely very friendly. It's I mean, quite frankly, it's like one of the nicest little corners of the internet that I have ever found, at least, which does make it really enjoyable to spend time there, helping folks out and seeing what people are working on and all of that sort of stuff. So head over there if you want to get involved. Another thing you can do if you are getting into development, or if you're already a programmer, you can come over to circuitpython.org and click on contributing. This page, it's going to list out all of the open pull requests and all the open issues. So how folks, how we usually get folks involved is by starting to review pull requests. Like if you go find a pull request that you have the, maybe you have the hardware for it, or maybe you are just interested in whatever library it is, and you want to take a look over whatever changes in the pull request and just offer your thoughts. Like, if you think there's something that could be done different, or if you think it looks good, or if you have the hardware and the ability to test it out, you can test it out and, note down that it either worked or didn't work or whatever. And so that's kind of the first way that we tend to get folks involved. So head over there if you want to do that. There's also open issues, which it's a little more advanced than reviewing, because you will actually be making the changes yourself and submitting a pull request. Sorry, I got a little bit of an itchy nose today. But this one's cool because you can actually start doing some of the development yourself, submitting pull requests and getting your changes merged into the CircuitPython library. So there's a big list of open issues. Right now, a lot of them are these missing type annotations, which are pretty good ones for folks that are brand new, either to the CircuitPython project or to some extent even to programming in Python generally. Essentially, these some libraries have more or less things to do. If you click on one of them and head over to the page, you'll see a list in the issue description here. Like this one just has 3 different spots where this needs to be done. And essentially it's going through and adding type annotations to the functions, like what types are the arguments expected to be, what types are the returns that the functions return, that sort of stuff. And so you just kind of look at the surrounding code, look at the examples, figure out what type those variables are going to be, and then add them in. Another way you can get involved if you don't necessarily want to, or I should say another way that you can support the project if you don't necessarily want to get involved, is heading over to adafruit.com. This is their website here. They're a hardware and software company based out of New York, and they make a bunch of the different microcontrollers. They also make all kinds of different doodads that you can connect up to the microcontrollers to do with them. So, on the front page here, we got a decent selection. There's a servo. There's a newer ESP32S3 dev kit microcontroller. Got some big old clacky switches. They've got basically, again, kind of all kinds of these different little widgets that you can connect up. Almost anything you could imagine as a little electronic, doodad that you can connect up to a microcontroller. They probably sell something like that. So if you purchase hardware from them, you are helping support the CircuitPython project, because they are the folks that are providing the primary financial backing for the project. They pay the core development team, they pay the folks that help foster the community around it and work on the libraries and all kinds of stuff. So they are currently employing the folks who are essentially working and running the project. So if you buy some hardware from them, you are indirectly supporting the project as well. So that's always a nice thing, and you get some fun toys out of it, which we will after. So I'm going to start out today diving back into the core a little bit. I think last week I did 2 streams. I did Friday and Saturday last week because Scott was out. And on the Friday stream, I worked on troubleshooting an issue in the core. And today we're going to continue a little bit on where we left off there. And then after that, I do actually have some fun toys that I got in from Adafruit this week. And so I'll do an unboxing with that, and we may play with those a little bit, depending on how much time there is. Okay, so introduction out of the way. And like I mentioned, We're going to continue on where I left off on that Friday stream last week. Basically, we have this just as a quick recap for folks that might be new or didn't catch the last one. I have this Raspberry Pi Pico. There is currently a bug that causes it to kind of hard crash sometimes, not 100% of the time, but a good percentage of the time. It will hard crash when you try to save data into the NVM storage. And so that's what we're trying to understand, diagnose, and resolve. And last time on that stream, we hooked it up to GDB. That was a neat learning experience for me. That was the first time I ever did anything like that. We got some stack traces, and I put that information back out onto the issue, and then Scott was kind enough to take a look at it and let us know what his thoughts were, which of course is really, really good because Scott's going to have a much better idea of what he's looking at with those stack traces than I was. Let's see here. It's not quite on the first page, I guess. Open NVM. Let's try this. There we are. Okay. So I had collected these stack traces using GDB, and Scott mentioned that thinks the issue is that we shouldn't load code when we are writing to the flash. So interrupts should be turned off during the write. These signal handlers show that this isn't the case. Since the stack is corrupt, I guess is what's going on here with number 5 and 6. The way these are question marks instead of having like actual text that tells us where it's at. This apparently does mean that the stack got corrupted. And so the suggestion that Scott had was add some more prints into the core to try to figure out where it's getting stuck. And then once we know where it's getting stuck, we can disable the handlers before that and then re-enable them after we're done writing to the flash. And hopefully that will resolve the issue. So I did actually make an attempt at that, but I did not quite do it correctly. So I made an attempt. There's another post here with some more information about adding some prints and trying to figure out where the last line was that it runs before it hangs. And I did actually, I haven't posted it, I don't think on this issue yet, but I did also actually end up trying the disabling the interrupts and re-enabling them afterwards. But I think I did not, two things really. I think I did not maybe do it in the right spot, and I think I also might not have done it the right way. So let's see, what I ended up adding was, I've actually done a bunch of prints in here now. I've got all these prints, and I added this common HAL MCU disable interrupts, and then there's a couple spots where it re-enables as well based on the different branches, because this is basically like a couple of different if statements, right? We have like this high level if statement. We have this next level down here. We have the next level here, which is, I think when it, based on the name here, I think this is when you're doing a slice operation on the NVM, which is one of the operations that does have this issue. And so I tried disabling in here, and I had tried re-enabling, I think right before it returns, somewhere down here, yeah. And then since there's other branches of logic, I also tried re-enabling on some of the other branches of logic as well. And I started playing a little bit as well with the single index write instead of the slice. But none of that actually did solve the problem. And I'm guessing the reason why ultimately is kind of where Scott pointed me next, which was we want to modify the port-specific code inside the common HAL folder, not in shared bindings. I made my edits inside shared bindings, but it turns out that's not really what we want. So I think what I'm going to do is, I think I'm going to take back out or just comment out these for now. Disable, actually, I guess I probably just have the one, right? So enable. We're going to turn these back off. I'm not going to do this here. And okay, we just got 2 of those. We commented them both out, so we should be good there. And then I will do what Scott said, which is go look inside of the Common HAL code inside the port. So we're under ports, we're under Raspberry Pi, Common HAL. There's NVM here as well. So let's look, and it doesn't have anything. Byte array. So we have set bytes inside here. All ones true. Okay, interesting. This is just checking if every bit is a 1. If it is, it looks like it has different logic. And if it's not, then it does an erase and a write. And then it returns true. So one thing I'm not super sure about is basically how we jump from shared bindings byte array C over to Common HAL byte array C. I'm not sure which order these things occur in. So the first thing I'm going to do is just add some prints inside of the Common HAL ports as well. I was putting line numbers in these, but they've gotten all shifted at this point. Like this one says, 119. This used to be on line 119, but it's not anymore because I ended up adding even more prints in. So the line numbers don't match up, but they're fairly close, and they all have different messages anyway. So we can still tell them apart. So what I'm going to do is take my print, which I don't have dedicated to memory yet, but I do know where to find, and copy paste. And I guess we'll go inside of here probably. So looks like this is defining the function. I think I'm gonna probably be, I'm not gonna do it like right now today, but I do think I'm gonna be getting this IDE, CLion. It's the JetBrains IDE for C and C++, so like I use PyCharm a lot. I'm even using PyCharm right now for this, even though this is actually a C project. But CLion is their IDE for C code. And I think the time has come that I actually mess around enough inside the core where I would get a lot of benefit out of that. Because it'll give me the ability to use lots of like quality of life features that I've grown accustomed to from PyCharm and Android Studio as well, actually. But I'll be able to use those in the C code, like control clicking things in order to go to where they're defined is something I use a lot. There's also lots of other nice like type hints and other kind of little IntelliSense type pop-ups that help you finish code. So I think I'm going to be picking that thing up pretty soon. So it looks like we're defining this. I'll put a print as the very first thing inside of here. Inside this. And I'll stick the line number on it. But again, if those get shifted, it's really no big deal. 74. Basically, I'm just going to put a bunch of these in here so that we can see kind of where it hangs. So we'll just look at whatever is the last thing that got printed. So this one is after we called get bytes. After get bytes. I'm also going to put ports at the beginning of these, since these are in the ports folder now. Because I still have a bunch of prints in shared bindings. This will make sure we differentiate between them. So this is going to loop and then either break or get to the end of the loop. So this is after, oh, I want to keep that though, ports after check all ones. Check all ones. 86. What you working on today, Dexter? I saw you posted that little bubbles example. I was taking a peek at that right before I got on the stream here. Is that a, looked like it ran on something with LEDs instead of like a traditional display. Is it like an LED matrix or a RGB matrix or something like that that runs on? Print. Let's grab another one of these. So if it was all ones, we'll do this. Ports inside all ones. If 89. So let's see, we're signing a couple variables. Bubbles runs on the Pi 0 with HDMI. Oh, okay. That's really cool. Pi 0 2 W. Yeah, I need to get mine. Just watching it run. Yeah, I can definitely relate to that. Like LED animations, that library will do that to me. I'll get something running to test it out or whatever and end up just like sitting there staring at it for a while because it's kind of mesmerizing. Interesting. Yeah, I need to get my Pi set up. I'm glad / excited as well that Scott's working on the Learn guide that documents the process of how to do all of that. I've been watching the deep dives, and so I could go back and reference that to kind of follow along, but it'll be really great to have that stuff documented in text in the Learn system. Oh, nice. TFT Featherwing 3.5. Yeah, I've got a super old one of those. I've got one of those that's like got the header for the original Pi that had the shorter header. It was only like 2 by 25 or something instead of 40 or whatever the current ones are. That's what I do most of my Blinka display I/O testing when I'm not running the Pi game display to make it work on my PC. The other context that I use Blinka Display I/O is on one of those 3.5-inch TFTs. I do really want to get that Pi. I picked up a Pi 02 W as well, and I am interested in getting it set up with CircuitPython. I'm super excited to play with Display I/O coming out of the HDMI port there. 93. And this is after we made some variables. Okay, length. This is still inside of all ones. Inside a loop. We probably don't. Yeah, I think we probably don't want to print inside of here. I guess I don't know how many times it's going to loop. Suppose it depends on write length divided out by something. Write page. Basically, as long as length is not 0, I'm guessing. Pretty easy to get the Broadcom going. Oh, nice. Nice. Yeah, it looked like based on the deep dives, it looks like Scott's got the majority of the like real actual hard work done, which is really exciting for me as well. Like being able to play with that stuff. I guess we could go ahead and do one inside of here. Why not? Right? It's probably not going to run that many times. So this is inside while length. .96. It's making a write length variable, and then it's doing the actual writing. So I'll do one before and then one after this. Before write page 98. After write page 100. And this is all just math with variables. I don't suspect that that's like a likely spot where we're crashing. Yeah, I think well, yeah, I'll put one after. After update vars 105. And we'll do one in here as well, both before and after. Before erase write set sector. Erase right sector 108. Paste after put my E off there. Okay. 110. Oh, you know what? Let me just realized I don't have got the Twitch chat hidden there. Let me shuffle that back to the front. Okay. Okay. So okay, I don't think we need one before we return true. There's a print here, which is right before the while loop. So if the while loop doesn't run at all, then the next thing that would execute is the return. So we basically have a print right before the return in the case that the while loop doesn't execute. We also have one at the end of the while loop. So if it does execute, no matter how many times it goes, the last thing we'll do is print, and then the next place that we would go is return. And then inside the else here, we've got a print at the end also, which would also be the last thing that runs before the return. So I think we're set there. I don't think we need another print here. So I'm going to save this. I'm going to build for the Pico, which I will need to change directories. And this make board CircuitPython. Try that. I may need to do a clean or no, these will print to the serial console. Yeah, so we don't have to hook up the debugger. We can just look in the serial console, which is the nice thing about this for sure. It was a really nice tool to add to my arsenal to be able to get GDB hooked up. But these are nice because they're, if I understand it, this is basically like when you call print from Python code, like inside of CodePy, this is like the core function that is actually getting called when you call that Python function print, if I understand correctly, which like very possible I don't, but it does have the same effect as just calling print in the Python code. 1 second. Grab a chapstick here. All right, much better. Let's see. And we need to go to bootloader mode. Okay, we got a successful build. We need to go to bootloader mode so that we can write that build we just made. I believe I still have this set up so yellow wire here is on reset. We need to jump it to ground twice. Put one of those right there. Well, two of those. Let's see if we got it. Yep, RPy2. And I think I have, maybe it looks like I changed that one. Let's go cd build Raspberry Pi Pico, CP firmware, UF2 media, user, RPy2. I started using this cp command in the terminal to copy the firmware because it's nice. I don't have to bounce back and forth between like File Explorer and everything. So I will go back to here. I have TO loaded up already. I think I have an empty CodePy still. Yeah, except for a comment, we still have an empty CodePy. We're gonna go to REPL. We are gonna pull up a couple more pages here. CircuitPython, docs, NVM. You know, one thing I should do is make a file, actually, with this. I don't want to put it in CodePy. Since it does hard crash, I don't want to get stuck. I think I'll just go code NVM crash. And let's go import. Actually going to make two of these. I'm going to make actually, let me rename this one code NVM read, and then copy paste NVM write crash. Okay, so here we're just going to say print microcontroller NVM 03, and this one doesn't crash, or it hasn't yet in all of my testing, but the write is where it does end up crashing. So this one is, we will do this, and eventually I'll change these bytes around as well, maybe to make sure that we're actually seeing them get written correctly. And now we can just go import code NVM read. Okay. So you can see we got a bunch of our prints here. These are a bunch of the ones I added to the core. It did print my byte array. Everything seems fine right now. We do have different values than what we're about to write. We have the 0 in the last bit here, or byte I should say, and the 2 in the last byte here. So it is different. We'll be able to tell if it works. So I'll go, you know, I guess one problem is that if we import this, we can really like only call it once, huh? Maybe we'll put it into a function, then we can call it over and over. Import, I'll import it once. Let's see, code NVM write crash. Let's see if it crashes. It did. And it crashed literally in the middle of printing a line. We only got one print inside of ports. So all of these are from inside of shared bindings. You can see I added a lot of prints. But we only got one print inside of ports. And we didn't even make it all the way through it. Oh, also oh. Actually, it looks like I forgot ports on a bunch of these. Let me put that in. Let me copy it with the space. So that's interesting that it failed like in the middle of printing. Which I guess makes sense, right? If interrupts are ultimately the cause, then, you know, it could be happening pretty much any time, I suppose. Okay, and this was which one? This was inside common HAL byte set byte. It was trying to print this one. And that's where it crashed. So I'm gonna do it, I'm gonna rebuild this, and I'm gonna try it one more time to see if it goes in the same spot or not. So we'll make did it actually make? It seemed way too fast. I know it does go, and it didn't say any of this stuff. Oh, I didn't save. Okay, probably knows it didn't change. There we go. Yeah, that's pretty fast too, but it did print the right stuff. Okay, so we need to go back to bootloader mode. Double tap our jumper cables here. I need to get a button wired up. Got it. I'm getting better at doing it with these jumpers, though. Let's see. This one, we can do this. Copy. All right. Now we're running. We're going to go back to here. Back to the REPL. Code NVM read. So this time we did get the exact outcome of the failure mode, which is it seems like it does override them with all Fs. A few of the times I've run this, I've seen it where it hangs, but it actually does save your bytes there, which is interesting. So we got our read, import code, NVM write crash. Okay, this time it's succeeded. We got our next prompt on the REPL, and we printed everything. And one of the things this tells us is that shared bindings goes first, and then we go inside of ports. And in this case, we did go inside of the check for all ones. So that must not be checking if we're writing all ones, but instead checking if it's currently got all ones. Which it does, because that's what it does some of the times when it does hang. Erase usually writes all ones. Okay. When you write, you're just changing the ones to zeros. Okay, that does make sense. That's why, so it kind of like succeeds the erase, but then fails the write afterwards, which leaves us with all ones. That makes sense. And so this is actually checking, I guess, what's currently in NVM, not what we're actually writing. So I suppose it's basically, okay, so it's basically if we already have all ones inside the NVM, then we don't need to erase, we only need to write. Whereas if we don't already have all ones, then we do need to erase and then write afterwards. So that logic does make sense. And again, this does tell us that shared bindings goes first, and then we go inside of ports. And then at the very end, we actually jump back out of ports into shared bindings again, because this one is inside of shared bindings. And we did make it successfully, so I think what I'm going to do is run it a couple of more times to try to make it fail, and then once it fails, we'll see if it fails in the same spot. Def write I think I'll make this take the byte string. It's going to be hard coded to 3. I'm just going to make sure to not pass it a string that's different than 3 length. I'm also going to leave some comments that I'll be able to copy paste. And actually I want from import write okay, this way we'll be able to call write over and over again. And we can always edit the bytes we give it. I think I like to do that with read as well. Def read read. This one doesn't need a parameter. Read. There we go. Okay, now we got some reusable functions. What is this? 2 blank lines. Sure. Be another blank line. Okay. So we're gonna go reset back to REPL and grab this. I'm going to make these actually like this so I can copy the whole line. Oh. I have a hotkey that copies the whole line. I don't know what it is, though. I need to learn it and commit it to memory better. I would definitely use it if I remembered which one it was all the time. It's very helpful. I'll take a quick little detour here and look up which one it is. Let's just go files, I think. This is configured in .config evdev. This here. We're probably looking for something with a Control A. Control. Okay, that's not what we want. Not what we want. We want like, well, it's not Control A, I guess. It's the one, it's got to be using home or end. Here we go. Yeah, this is what we want. And it's on whichever button is normally C. So part of my problem with this is not very visual, and I don't remember just like which one is C on my little macro pad here. I'm gonna do is open a new text. I'm gonna kill this program, which is what's converting. Okay, got it right on the first try, so maybe I did know what it was. This program is what's reading that config file. It's basically like a macro pad hotkey thing. Okay, so we imported read, and now I can just go on this line, press one button, and I should have that line copied. Yeah, I can just paste it right there. Read, okay, we got our byte array. So now we're gonna go here, we're gonna copy this line, paste it, copy this line. Yeah, I'll paste it, but we'll change this. Since we already have this written, I'll change it to a 1 so we can tell if it's different. Okay, we did not crash at the same spot. Last time we made it partway through this print. This time we made it all the way through to before erase right sector. Right here. So theoretically, we hung inside of here this time. So it's not at the exact same spot every time. I think what I'll do is well, since we only made it partway through this one, I guess we'll try to disable the interrupts here, like as the very first line inside of this function, and then re-enable them here right before we return. And this is the only place that we return from, so we should always be returning from here. So we should just need the one enable. I'm gonna grab this. And so here's the other thing that I think I might have done wrong last time is I just called this function, but I don't think it's imported. I'm actually surprised that it compiled, truthfully. I don't know if I kind of think I need to import it. But I'm surprised that it didn't just break when I did it before. So we're going to put this here, enable right before return, disable as the first line, and I'm going to try to actually see if I can do the import right. So yeah, we're not currently importing where this comes from. And the way I found how I think the import is supposed to work. Whoa. I don't know how that bounced over to the other window. I came here, back to the root, git grep this. So then I found where this was done. Actually, q git grep -n. I want to make an alias that whenever I run git grep, it will always pass -n, because these are super helpful. I can click this and it will take me to the right spot, which is really nice. Actually, you know what I'm going to do is look at the... I don't think it necessarily matters which one I look at, but I'm going to look at the exact same one that Scott linked me, which is here. And I think this is... I think this is importing from here. Third bindings microcontroller init. Let's see. Microcontroller. H. Enable. Yeah. If I understand correctly, these are defined... Yeah. These are defined here. So I think we need to import them. Or include them. Yeah, it's called include in C code, but I think we want this. We're going to put that up here. Not sure if the order matters. I didn't think so, but maybe. Save that. Let's make a new build. While that's running, let's do our double tap. Jumper wires here. Okay. Copy this. I'm gonna grab my gloves real quick. It was a little warm when I started, and I opened the window right by me. Now I'm on the chilly side, but I kind of suspect if I close it, I'm gonna get warm again, so throw some gloves on, see how that works for us. So now we're back to CircuitPy. We're gonna come back here. Excuse me, we're gonna come back to here. And one of these is TO. I accidentally clicked off of it. Guess one problem is this is gonna close the files I have open every time. Okay. So that one succeeded as well the last time. Even though it hung, it did write R1. Which is interesting. Whoops. I'm gonna restart. Not sure what that hotkey would have done. Maybe nothing, but rather get a clean test here. Okay, we already have a 1, so 0 is fine. Run it. Okay. So first test worked, but remember it doesn't crash every single time, so not necessarily out of the water yet. Let's try a couple more times. Read. We did get our value saved in it. We'll copy this again. We'll change this one up here. Call it an F maybe. Okay, we got 2 in a row. Okay, let's keep going. Let's keep going. Read. Let's call read again. Okay. Let's call write again. 2. Fingers crossed. Okay, 3 in a row. Getting a good feeling about this now. Read. Right. Another one. Okay. Now the next thing we're going to do is on this thread, it mentions, which Neradoc noticed, if you write to CodePy, it doesn't really matter what you write, or it doesn't seem to, but if you modify CodePy and then try to write to the NVM, that seems to make it more likely to fail. So that's going to be our final test. We just got 4 in a row. I mean, not final. I'm going to keep testing this, but we got 4 in a row. So far, we succeeded 4 in a row, which is good, but not unheard of. I had a couple of streaks of successes before as well. So we're going to just go to CodePy, modify again, save this, and now write. Actually, I'm going to read first. Read. Okay, we have an 8, so I'm going to write a 6. Oh, we made it. We made it. We might have just solved this. Read. 3. Oh, yes. 7. Oh man, this is great. Right? We have not failed yet. Read. Okay, modify. Another line. Save. Oh, yes. Right? Let's just try write twice in a row. T is interesting. Not sure that's what I was expecting. That might just be how it displays bytes. Hasn't hung yet. Oh, 8. Yeah, that might just be how the 9 works. T is the character for 9. I see. So I'm gonna go right. I'm gonna do another right. I'm gonna do a third right. Now I'm gonna read. Looking good. Looking good. Oop. Definitely need that. Ooh, got a comma on that one. Whoop. I don't think I can do undo. C4. Nice. I think we solved it. How's it going, Squid? Squid.jpg, thanks for tuning in. So yeah, I definitely have not gotten a streak this long of successes prior. Okay, yeah, let me grab that. Yeah, unfortunately, there's I think that's a thing going around right now. It seems to be popping up on lots of different YouTube videos, including mine. Unfortunately, let's do this. Thanks for the heads up. I appreciate that. Oh yeah, got a bunch of them, huh? So I don't understand. Like, this is the most low-hanging fruit of obviously spam and obviously against YouTube's terms. I don't get how they even made it around some kind of auto. Oh, I can hear myself. Hold on. Volume down. There we go. I don't understand how Google's system is not good enough to stop this. This is like plainly obviously spam. It would not be difficult at all to notice this and just automatically prevent it. But yeah, good to hear. Okay. Again, thanks for the heads up. I will I think I'll maybe just leave this one here, but I'll pause it. I don't know if does the chat keep going if you pause a live YouTube video? Notice this one's running too. I'll pause that as well, actually. Oh, we already got more. We seriously already have more? There's actually more, or do they not disappear when I report them? I need to still figure out how to just disable YouTube chat, honestly, if that's possible. I feel like I've seen videos where that's happening. Because I don't really have enough room on my screens or enough attention, truthfully, to watch Discord and Twitch and YouTube. Yeah, they're just coming back when I refresh is the deal. So I'm reporting them and they're hiding, but as soon as I refresh, they come right back. Let's do this, I guess, instead. Hopefully reporting them will make it more likely for YouTube to just fix this without content creators having to worry about it. Okay. Can I disable chat from here? No. I'll have to look into that. Under edit video? Restrictions? None. I'd like to restrict chat. Playlists. Alright, we're gonna get back into it in just a minute. Taking a quick detour here. Blocked links, blocked words. Blocked words. Maybe I'll do blocked words. Hold potentially inappropriate chat messages for review. Yes. Allow all comments. Hold all comments for review. Hold all comments for review. I'm gonna do that. Hopefully that will, unfortunately that means like I don't think anybody will be able to put any comments on the YouTube. But again, Discord and Twitch are the places to go if you want to chat. Discord is on the screen there, and I'm trying to watch the Twitch chat as well. So if you want to get a hold of me, those are the two places to do it. Okay, this is amazing. I think we did solve this. So we need to get a branch ready to PR it. We need to take out all the prints and then make the PR. Excited about this. Nice. Yeah, I actually just bought, I got an order this week, and one of the things that I threw in that order was a couple of FRAM chips, with the thought in my mind being like, hey, if I can't get the NVM to work, maybe I can use this other thing to save stuff. So I'm really excited about getting this to work, but I do still kind of look forward to playing with those FRAM chips. I've never actually used any of those before. So we're going to go back to CircuitPython. We will, I think I'll make a new branch. This one's called NVM prints, which that's not really what the final fix is going to be. So let's go back to the root, git fetch data fruit. Oh, you know what? Dan mentioned, let me read this real fast. Dan mentioned something about whether to use main, something else, I think, right? We branched 7.1x a few hours ago, so we could do some incompatible stuff in main for 7.2 or later. Fixes for 7.1.0 are better PR'd against that branch instead of main, so we don't have to backport. So I think this applies to what I'm doing. I mean, ultimately we could PR it to main and then it would eventually come in with 7.2.0. But if possible, it'd be nice to get it into the 7.1 final release once it's made. So I think that this is what we want to do. Whoa, where is my listing of people? Is it because of streamer mode? Maybe it's because of streamer mode. Oh. Whoa, I had no idea this could be toggled. Huh. I'm gonna ask, actually. So there's a branch, so I'm gonna do a little bit more looking and see if I understand this. There's a branch called 7.1x now. Yes, okay. So I'm gonna say this. Seven one X. Okay, I think this is right. We'll see if Dan is around to answer. I'm pretty sure Dan will know the answer to this. If Dan's busy though or not around or whatever, then I will, I think, just try it this way. And if that's not what we need, then I can go back and do it the other way. Wait for just a minute. Actually, while we're waiting on that, I'm gonna go put my coffee cup in the kitchen and I'll be right back. And I'm gonna get a little bit more ice in my Okay. Nothing from Dan. So I will just do 7.1x, and then if that turns out to not be the case, we'll go back and do it from main. It's only gonna take a minute anyway. So git checkout b rp 2040 NVM fix from Adafruit, not main, but 7.1x, no track. Commit. Yeah, it's fine. I can commit on this branch. Oh, I don't know why that's different though. So that's something else I tested actually. I mean, ultimately, this branch doesn't matter. I'm not really going to use it for anything. So I don't know if these were supposed to have changed or not, but I don't think it matters. So yeah, we're going to push like this. Wrap the URL in angle brackets. Oh. Yeah. I don't know. I have a vague idea of what this means, but I don't really know why, like how I got to it. I mean, I know what I did, which was test a PR that updated stage, but I don't know why that took me to this state, and I don't know the exact right way to get out of this state. So hopefully, once I do this, we have a fresh branch that's not got any of that stuff going on. I'm going to close all these. We basically went to ports, Raspberry Pi, NVM, inside of here. Set bytes, I think this is where we were at. You know, one thing we should have also tested still is single byte writes. Everything I did was a slice, and I know there's different branches of code for single byte writes instead of slices. So we'll test that as well. We're gonna have to make a build with this new branch anyway. So, so we were in here. We did it right here to disable, and right here to enable. Whoop. Yeah, thank you for that tip, by the way, about the angle brackets. Yeah, I always find myself Xing out the little one box because it's massive and it pushes the chat a bunch farther up right after I link for the most part. And it's nice to be able to do that. I did not realize you could do that. It's nice to be able to do it all in one shot. Just put angle brackets around there. I'm gonna go here, enable. And I do think we need that import. I mean, we could try it without the import. It wasn't crashing when I did it without the import before, but I really think it probably needs it. I already have this open and copied even, okay. Nice. Yeah, there's so much stuff like that with Discord where little shortcuts and things. I'm gonna do a clean build also. Just in the kind of utmost caution, essentially, to make sure that my old one is not in the mix and that we definitely have a, a fully built solution that does solve the problem. I'm actually going to go ahead and close the window too real quick while that's building. All right. It's getting a little chilly still, so I'm sure it's going to warm up pretty nice today though, so I'm guessing we'll have the windows back open a little while later. Nice, frame is great. I use the I2C one. Best part is I can reclaim it for something else. Nice. Yeah. I'm super excited about this fix as well. The place where I actually discovered this is I was working on a Pac-Man style game for the Raspberry Pi Pico. And I wanted to change it up. I want it to be like, basically you collect the ghosts, and it's not just points, but you can eventually like spend your like ghost points to do other stuff, like make your Pac-Man better. Maybe the Pac-Man will move faster, or maybe the Pac-Man will be able to grab pellets from farther away, or different stuff. Like I want it to be, you catch the ghosts and then, spend the ghost, points or whatever, to get upgrades to your Pac-Man. And I wanted to store the information about how many you collected and what upgrades you had. I wanted to store that in NVM, and that's when I noticed that it crashed on this one. So I'm excited as well to get this fix in so that I can go back to making that game. We're going to double tap our jumper cables. That's going to hopefully get us to bootloader. Yep. We will copy. Nope, wrong terminal. Copy here. Whoa. It just disconnected? Maybe disconnected? Maybe this gave it focus? I don't know. I didn't touch anything. I don't think. No such file or directory. So I think I'm in like a phantom. Even though this has the same name, since I make cleaned, it would have got deleted. And I think my terminal would be left in like the old one, which actually got deleted, which is weird, but somehow I think that's what happened. My uses maintain, made a macropad thingy with some arcade buttons, use it with 2 computers. Wanted to remember which config to use across boots. Ah, that's pretty cool too, though. I like that. I'm a big fan of like practical stuff like that as well. Like anything you can do to make your little, microcontroller, however you're using it, especially if it's a macro pad. Like I pulled up my macro config earlier. It's not for an actual macro pad, the device, but it's a very similar kind of thing, and it has a config and stuff. And I'm all about like trying to make that as practical and helpful as possible. So sounds pretty cool as well. So we copied, we're good. We got CircuitPy back. We will go back to here. We'll do a couple more tests. Did anybody ever mention anything here? No, not yet. That's all right. This is the PR that I reviewed. I'm going to take another quick peek. Okay, merged. Oh, no, this is not the PR I reviewed, apparently. Same. Oh, okay. So maybe this got done in both. Maybe this got done in both branches, and that's what Dan was talking about, is it could be just 71X. I'm not sure. What's that? Here. Grab our files. I'm going to do read first, read, paste, read, paste. Okay, we got C4. Import, right, paste. Okay, we have no more prints, so nothing printed, but we did get our next REPL. Read, we're good. We'll just kind of do a couple here. Okay. Good so far. Oh man, this is really exciting for me. Like, I've never, I don't think I've ever, like, really fixed anything this complex in the core before. And I got, like, pointed right to what to do by Scott, but it still was, like, a pretty, like, uncharted territory for me. Pretty deep dive, if you will. So even though I got kind of pointed right to it, this is still, like, super exciting for me to be able to have actually solved a problem and have it work correctly. Yeah, I'm thinking we're good. It hasn't failed once since we got this in, so once I make the branch, if folks, Squid, if you want to try it in your situation, if you have the ability to do that, it'd be great to get as many folks as we can to try it in all the different devices where this was noticed. So I think we can pretty much go ahead and just make the PR. Need to do anything else? I guess, does the core has pre-commit, right? Should I leave a comment? Let's look at some of the other spots where these are disabled. There are comments talking about it? No. This is on the wrong line. Oh, it looks like I did get a ping back. Yes. Then the fix will be an immediately 1.x branch there when we make the next beta. Nice. Okay, so we did the right. Merging the other way will bring things we didn't want into 1x. So we'd have to do cherry picks. Okay. That makes sense. Okay, so we did do the right thing. We branched from 1x. So none of the rest of these have comments, so I guess I don't know. I kind of want it. I do kind of want to leave the comment. If they don't want it, they can leave the review and tell us to take it back out. I think it makes sense though, because this is like specifically solving one. Oh, we needed to test single bytes as well. Since this is solving like one specific issue, I think it's good to just say disable interrupts to prevent core hang on RP 2040. That part goes without saying since we're in ports Raspberry Pi, I think, so maybe we don't need that, but and we probably don't need the comment for re-enable. That one's self-explanatory, I feel like. Let's make one more build. It shouldn't change because we just made a comment, but let's make one more build, run it, and then test single bytes as well before we make the PR. Double tap. There it is. Okay, RP, copy. There it is. Nice. Yeah, awesome. Thank you. Appreciate all the testers we can get for sure. Okay, copy. CircuitPy should come back. There it is. Go back to REPL. And I'll just do them by... I'll take my imports actually. Oh no, I won't, because those are importing directly the thing. Okay, yeah, we'll just go REPL import microcontroller print tab dot NVM 0. Was that 0, 1? Oh, okay. When you print 1, it just prints it as an int. When you print 2, it prints it as a byte array. Interesting. Okay. And then microcontroller NVM 0. So would we still set it as a byte string or just set it as an int here? Maybe it doesn't matter which way. Truthfully, I guess probably both work. So, oh, actually, when we use a slice, we get a byte array, even if our slice is only one thing. But when we don't use the slice, we get the int. Okay. B3. And convert bytes to int. Okay, so we do need to use int then, probably. I don't know what number B3 is. Doesn't really matter, though. 205. 205. Perfect. Curious, what does this come out? CD. Okay. Cool. Yeah, seems like we don't have any problem with single byte writes either. So slices work, single bytes work. I think we're good to go. So we're gonna head back here. I added my comment. I'll make a commit. We don't have that other stuff in our commit, so that's nice. We imported. We made a comment. We disabled interrupts. Whoops. Comment, disable interrupts. Enable interrupts right before we return. I'm gonna just double check over this, make sure that there's absolutely no, because I assume it's bad if we disable the interrupts and then don't re-enable them. So I'm gonna double check that there's no logic path that can result in not calling enable interrupts. So this is a for loop. This is not return, so this is not returning from the function. It's only breaking out of the for loop. So we don't need to worry about that. That's just going to break out of the for loop, and then we're going to go on to here. Inside the if, inside the while, there's no returns inside of here. There's no returns inside of here. So we just have the one return, which is here. We're always enabling right before we return. I think this is probably fine. Difference looks good. Let's run pre-commit before we do make the commit. I think there's pre-commit in the core. Q, pre-commit, run A. Failed. Does that run black for me? Can I just do it again? Probably not black though, I guess, right? Because it's not Python code. Yeah, it looks like it did run it again. Or I mean, it ran the, it changed it for me, so I don't have to do it. I'm curious what changed. It's tough to tell without a, I don't know, maybe I had an extra new line up here or something. Not sure what exactly changed, but it's a good thing we ran it because it would have failed actions probably. Oh. Oh. Actually, these are what changed. I didn't touch these. I'm not sure why those showed up. I think I'm gonna push without that. I don't know what these are doing. These, honestly, these look like file paths, and If they're actually file paths, I don't think the space would work. I think that would break it probably. I don't know why that changed. So I'm just going to leave only byte array checked. This is one of the nice things about PyCharm and the other JetBrains IDEs as well, I'm sure do this, is when you go to make a commit, you can just check mark on or off any particular changes, and then you don't have to include all of them in your commit. So we'll just only check mark byte array, disable interrupts inside ports common how, Raspberry Pi. Should be excluded from the formatting check. Yeah, it seems like it. Is that? I don't think, I'm not entirely sure what this is doing, but if that is actually a file path, the spaces, I would guess, probably should break it. Board C, this one maybe does. Well, I don't know, actually. I think this one might break something too. I'm gonna say this one maybe not much of an issue, but this is syntax for something, I think, to do with pointers. I'm still not quite up to speed on all of the C syntax, but I'm pretty sure that star is intended to be next to the bus, not... Oh, it changed. Okay, it used to not be, and now it is, actually. So that one does actually seem, to my eyes, like it would maybe be needed. But I don't know why it would have been checked in without that, and why the formatter would have noticed it. Board change is okay, yeah. Yeah, I think you're on the right, I think you got the right thought as well. That thing is like telling it where it can find libraries from, which is actually cool that you can find libraries from the SD card. I didn't know that until more recently. I thought libraries and all code had to be on internal storage, but it can actually come from the SD card, which actually could give you some interesting things you could do, like on a PyPortal. You're still limited by memory. I think I'm gonna not check this in still. I don't fully understand what it's doing, and I suspect somebody else, if it needs to be fixed, I suspect there's a different PR or some other thing in motion already to fix it. I'll mention it maybe on the PR, and then if they want me to go back and add a commit to do it, then I can do that, but I think for now I'm gonna just do this. Okay, so we'll check this. We have just our change in byte array, which is in ports Raspberry Pi common how. Triple check the changes here includes comment disable, enable. foamyguy RP2040 NVM fix push. And we'll go back here. This is the branch we want. And I think if I understand correctly, we also don't want to go to main, but we want to go here. And once again, we will check our changes, but this time on the GitHub side, we have the include, we have our comment, our disable, and our enable, and that's it. That looks good. Resolves, I don't know the number. 4867. Yep, that's the one. both, let's say both multi-byte array slices and single bytes with not had the device hang at all since making this change. With several NVM writes with both multi-byte array splices and single byte. I've not had the device hang at all since making this change. Tested on Raspberry Pi Pico, but I believe fix applies to all RP2040 based devices. When I ran pre-commit, noticed locally that it made some changes in ports Broadcom, qstring def sport, qstring def sport.h, and ports expressive words fruit feather ESP 32s2 word.c. Include those changes in this PR, but I should do that. Let me know. Make a new commit changes that it made. Okay. So I would think definitely, thank you, Scott. Definitely appreciate that. I would not have been able to, I would never have known to try the interrupts, and I definitely would not have known where to put them, because I did put them in the wrong spot, so hugely appreciate Scott's help. Great pull request. I think we're ready, right? Preview, make sure this is the right link. Yep. Boom. There we go. And that's really exciting to be able to troubleshoot this, figure out like enough that somebody else could read it over and tell me what the issue probably was, and then actually be able to follow directions to get it fixed. That's awesome. Okay. Perfect. So yeah, we got a little bit of time left still. So the other thing I'll do today is I have a new toy that I will unbox and we'll play with a little bit. I think what I'll do with it is, the other thing I'm working on lately is some built-in module examples for the core. But I can do that on this new device. So we'll unbox it and get it set up and then use it for making some more examples. Yeah, thank you, Dexter. I appreciate that. So this is one of the things I got this week from Adafruit. I made my order to get the pink feather. and I've been eyeing one of these Pimoroni Pico System little handheld gaming devices for a little while. And so it worked out pretty well because it covered a good chunk of the cost to get the pink feather. It was $99 to spend to get a pink feather, and I want to say this is like 70 or 80. So it's not like super cheap, but I mean it's relatively cheap as far as gaming handhelds go. And it seems like a really neat device to play with, so I'm excited to finally get one of these. So we got a RP2040 based device, so we could actually test our same fix on here if we wanted. It supports CircuitPython already, so of course that's what I'm going to be installing on it is CircuitPython. Comes with a battery, which is pretty cool. Aircraft grade aluminum. No, Zeppelin, excuse me. We're only Zeppelin grade here, so don't make an aircraft out of this. But that's fine with me. I don't know about Arduino, but I do know that you can use CircuitPython with it. Arduino, I actually did more with Arduino this week than I have in years and years and years, and truthfully, what it left me feeling was super grateful for how easy CircuitPython is. Honestly, I did some work this week on testing a PR in the AVR prog library for CircuitPython, which is a library that lets you write programs to Arduino devices, not like write CircuitPython programs to them, but use a CircuitPython device to write compiled Arduino code onto an Arduino. And Arduino's like, it's just finicky. Like the writing, it just doesn't work all the time, and the errors are mysterious. Since I don't have that much experience with it, I'm sure if I learned more, they wouldn't be. But so yeah. Anyway, long story short, I don't have a whole lot of experience with Arduino, so I cannot answer that part of it. But it does run CircuitPython. That part I'm pretty confident because it's listed on CircuitPython.org right here. Pico system right there. So I'm not exactly sure when this came out, but it's long enough ago that it got 7.0. Wrote the AVR ISP sketch. Now I use CircuitPython. Now I'm happy. Nice. Yeah. Okay, RP2040 is still spotty on Arduino, but CPU is good. Nice. Yeah, I'm sure probably the Arduino support will come along eventually. I don't know why this is showing. These are unread. It's bounced me up there. So let's go back here. We'll open this up. It's got some plastic wrap on the outside here. Take that off. There we go. Hopefully that's not too loud coming through the microphone. Do that. I'm gonna just step away 1 minute and throw this little plastic wrap away so it's not showing on my desk here. All right, and we'll zoom out just a little bit more. There we go. So let's see, we'll show you all the sides of the box here. Tiny Gaming Dev Handheld. Ecosystem, Tiny Gaming Dev Handheld. It's made by Pimoroni. Can't read that part, but they've got the URL there, Pimoroni.com Ecosystem. Guessing it's got some more on this side. Not actually sure which way this goes. So we saw that side. Made in Sheffield, UK. Guessing that's a part number, Pimoroni 559. So let's see, it looks like this slides out maybe, but it does have a bit of tape here. I just grabbed the knife. Not too worried about trying to like keep this together or anything. I'm definitely keeping it. It's not going to be returned or anything. There we go. All right, we got our tape. So yeah, looks like this slides out now. And let's go maybe this way. There we are. So we got digital eject button. I'm not sure what that does. Comes with a lanyard hidden inside. Got a little diagram of the top there. X plus power equals flash upload. Oh, okay, to get to bootloader mode. So hold X, which is the top button here, and then press the power. So the X doubles as boot select, it sounds like. And let's look. We'll take this out. We'll set that there. Looks like we got a diagram inside there as well. Status, D-pad, XYAB. We got a nice 240 by 240 screen in the middle there. On the back. EcoSys got another URL. Nice little exploded diagram of the parts on the device there. And it looks like what else we have in here is going to be a cable or a cord, maybe? Yeah, I'm with you about making the games in CircuitPython. It's definitely what I'm heading for with this thing. So that's going to be the wrist strap. So it looks like got the little thin wire on this side. You can hook it in the little hole that's right here. Attach that thing to your wrist. There's a couple screws on the back. USB-C on the top. That one's power, I believe, up there. Looks like we got maybe a little status LED there. It's got some heft to it. It's a nice, like, it feels like a nice little sturdy device. Like, you know, if you bought a little Game Boy or whatever. Feels pretty similar. So, yep, I think we got everything out of the box there. So, let's plug it in. I guess it's got a built-in battery, so maybe we could try powering it up. We just press power. Oh, yeah, it comes right on. Look at that. We got Scorpion Games UK.itch.io. Let's pull up their page. Looks like they probably made the preloaded thing here. Scorpion Games UK.itch.io. Scorpion Games, there we go. Indie game dev. C++, Python, Java, make music sometimes. Got a 32-bit, made a larger project for Super Square Bros. Available for Pico system. I'm guessing that's what game is loaded on here, maybe? Or kind of a puzzle platformer with a twist. Interesting the way this page scrolls. The left half is static. 2D rocket simulation. 1 second, actually. Hold on. Alrighty, sorry about that. 2D rocket simulation. That sounds pretty fun. Oh hey, I can scroll here now. Interesting. Got a snake game as well. Alright, so let's see which one we ended up with here. That's our logo. I'm guessing maybe if we go A button. There it is, yep. So play, settings, credits. Got a little speaker. I don't know if that's coming through. Maybe if I get up to there. Let's check out settings. Well, let's see, which one are we on? Okay, it doesn't come through the camera very well, but it's like one of them is orange and the other two are white, so it shows which ones we're on. Let's look in settings. We got checkpoints on or off, music on or off, SFX on or off, hacky fast mode on or off. It's A to toggle and then Y for back. So I'll leave everything default for now. So let's go Y, play. Okay, so we got two players here. Select player 1 or 2, so I'll go player 1. Alright, we can move back and forth. I think, can we collect this thing? Nope. Can get on top of these platforms though. Level 1, no high score. So I gotta jump on this. Yep. Press A to skip. Got a little cutscene on this level. Oh, it shows you all the way through the level. Actually, that's kind of cool. Go up here. Ah, there's our coins. Those are what we collect. It's like, you know, it's a bit like Mario, right? Side scroller. Oh, ran into the, there we go. Oh, uh-oh. There we are. Oh, wow, that's a nice little animation. Does that respawn? No, okay. Whew. Put a tree on that one. So I don't remember where our next one is. I'm guessing if I just go as far as I can. Yep, there we go. Oh, oh, there we are. All right, there we are. Oh, I can't get it from here. I gotta go up to this one. There we go. Oh, I missed my jump. All right. So that's a pretty cool game. Yeah, the clouds in the background are nice too. That's a nice little game. I am going to load it with CircuitPython though. I assume there's probably, if we hit this URL, Pymeroni Pico System, my guess is hopefully we can reload the stock one so we can get back to this game. And this is not plugged in right now either, so the battery had enough juice to run this. Let's see. Super Square Bros. Okay. So, I mean, they make it seem like you can load these other games. Not sure where you get them from, though. Oh, nice. Got a shout out to Deshipu there. Oh, these are links. There we are. Okay, so here's our dots game, and I guess it's probably is it a UF2 release? Ecosystem. Yeah, UF2 file. Okay, so that's how we reload them. So we can get back to out of box once we want to play this game again. I just wanted to make sure I knew how to get back before I start programming other stuff. So let's go beta. Save that. And I'll plug it in. Put the box over here for now. USB-C we got here. I'll probably go without the wrist strap. Honestly, I'm not much of a wrist strapper. See if I can feed this back in here. Easier to unfold it some, probably. Well, maybe not actually. Alright, well. Give it about like that. That's good for now. This, and let's get this plugged in. So we're gonna go USB-C. Oh, got a charge light. That's what that little LED at the top there must be. Charge light. I'm gonna pull this down a little bit. I'll put this back up here. Can't really see it anyway, I guess. So it said, what did it say on here? It said X plus power. X plus power. So hold, I'm guessing this is hold X and then press power. And then I think power once is probably off. Yeah, seems like we're off. And we have no drive. Yeah, we have no drive. So I think what we need is hold X, press power again. And then this time, when it comes on, we get a drive. RP2 right there. So now we can load CircuitPython. I think I downloaded, right? Yep. Copy that. Paste it right in there. And once it completes, it will reboot to CircuitPy drive. There it is. We've got our serial output, and it is probably too small to come through on the camera, but it basically printed hello world. So it looks like it got loaded up with a CodePy that just contains probably print hello world, I'm guessing. Yeah, there it is. No libraries preloaded, so we'll need to throw a couple of those on there. Here's our boot out. 710 beta. You know, if we wanted to, we could try to build this and then test this same fix on it. Feeling pretty adventurous here. Try to make this. I guess my make is going to include these changes, but I'm not doing anything with either of these files, I don't think, because this is not a Feather S2, and it's not in the Broadcom port because it's not a big Pi, it's a Pi Pico. Well, it's a RP2040, but we'll let that build. Let's head back here. Let's head actually back to here. Should be already connected, yep. One of the first things I always do when I get a new device is do board and dir board, see what the pins are looking like. So we got a backlight, audio, battery, sense pin. That's interesting. You can probably tell how charged the battery is. Charge stat, I guess maybe that's to do with that as well. We got a board.display. I'm always happy to see that, right? Display I/O is kind of my bread and butter, so we know how to hook that up. GPO and GP1. Got our SPI bus for the display. VSync pin, I don't know what that would do. Looks like we have a RGB LED. Maybe this one here, which is currently red, maybe that's actually an RGB. Got a RX, we probably got a TX somewhere, yep. We have another SPI bus. We have, these are the buttons. They're SW, I guess, for switch probably. Switch A, B, then down, left, right, up, and then XW. They're in alphabetical order, so. Got a UART bus. We got VBus detect. I don't know what that does. And we got our board ID property. Usually you get VSync interrupt just before the screen is about to refresh. Pin is probably related to that. Oh, that would make sense. Yeah, I could send the pin high or low whenever it's going to do that, one way or the other. And if your program knows which one it will be, then you could use that information. That's kind of cool. Did this build finish? It did. So let's try flashing that and then try our NVM code on it. So hold X and press power once for off and press power again for on. And then I think I could let go of X at this point. Helps prevent the screen tearing, I see. There's our RP2. So now we want to go this one, back up, build Pico, Pimaroni Pico. So this command is the same because firmware has the same name. And that appears to be the only LED, so that, I'm guessing that must be the RGB, or the only other thing is if this is not the RGB, then there maybe is an RGB that's covered by the case. Be the only other thing I could think. For here, we got back to CircuitPy. Didn't have any issues. I don't have my code to copy from, but we'll do this, microcontroller, print, microcontroller, NVM 03, should be F's probably, yep. Microcontroller, NVM 03 equals byte string. Go copy this maybe. We got 3 bytes. Oh, we don't need that. Okay. Read them back out. We got them. Yeah. Looking good. Here we are. So we got confirmation on a second device. That's pretty nice. And I think go for a little while longer. Maybe, I don't know if I'll go quite the full 3 hours today. I just still got a couple things to do today, running around and stuff, so. Oh, actual erasing and writing is done in erase write sector. I suggest moving disable to around those 2 lines instead, since that's the lowest level and will work for any use of that routine. You can see similar in internal flash. Which I think is where, thanks for the review, Dexter, I appreciate it. I think this is where Scott linked me. Internal flash. Yeah, it is. We go inside of erase, right? But some of them, doesn't it have that other branch that doesn't? Yeah, because this calls write page. So this is if it was all ones. Then it calls write page. Maybe it's not a problem unless it's erasing also? I think we would need it if we don't, if we go lower level one step. Yeah, I think we would need it inside of here too, wouldn't we? For the case where it was all ones. Give it a try. I think Dan is suggesting move this. Here. And re-enable here. I feel like it would need to be done in this too. We can test it though, because we can force it to be all ones somehow. Well, especially if we can make it fail. Although we can't, this would make it succeed unless they're all ones. I guess we can write all ones back to it. I've only been changing the first 3 bytes anyway, so I could just set the first 3 bytes back to ones, and then we should be back to all ones, I think. So let's save that. We got this device going, so let's just build it again for this. Okay. And we'll put the camera back. I'll go to bootloader, X, power. We'll say it's much nicer to get to the bootloader on this. I don't have to use the wires. Run bubbles. I will. Let me pull that up. Where did you, was that in show and tell or help with? Where did you link that? Ooh, UVJ's working on some cool looking stuff. Must not be here. Ooh, somebody's got a game going on the iGamer though. Must have been help with. There it is. This, I'm gonna grab the URL. Go over the chat. Let's go here. Let's go here. Does this need anything special plugged in? Release displays. I don't know what this will do though. This is only for the Raspberry Pi? Would I need to change it to just use board.display then instead of frame buffer IO? Can use, okay. Okay. Yeah, I'll totally give that a try. Let's see. Okay, we built. Did we come back as RP2? Yep. Kind of backwards here. I feel like build should be on the... Can't move them, so it doesn't matter. I'm pretty sure I've been able to move these in the past. No. Need display shapes and fancy LED. We can get those. Fancy LED, it doesn't have a NeoPixel pen. Does it need that? No. Just using fancy LED for some kind of routine that's inside of it, like wheel or something, maybe. These things. Okay. Okay, did we get CircuitPy? Yep. So now let's go here. Should have copied that stuff off of my Pico. Import microcontroller. I'm gonna do 0, 4. Yeah, the last one is F, so I believe the whole rest of everything should be Fs. So if we set the first 3 to Fs, I'm gonna use double quotes, I don't know if it matters, but... So it's not all Fs right now, but after we make this change, then it would be, I think. 4,096 bytes on this device. That's quite a bit, actually. Let's go F0 on this one. So it did succeed. Oops. We do have our 0. Well, I guess let's go back to Fs. Guess we could always put our print statement back and see if we go through the all Fs branch, or I could print more of it, maybe. Can I just print the whole thing? No. I could do 0. I mean, I guess I could just 4096, we already know what it is. Yeah, it looks like all F's to me. Okay. We got F's. I'm gonna edit CodePy since that seemed to be making it more likely to happen. Succeeded. There we go. It hung. So it'll disconnect in a minute. So yeah, I think we need this in both. Otherwise, if it happens to be all Fs, it can still hang. Do that. We'll build. Go to bootloader. Oh, that's off on. I'm gonna also, while this is kind of booting up and doing its thing, I'm gonna plug in my Pico. Oops, sorry. I don't know if that was loud. I'm gonna do this. I'm gonna get the Pico. I'm gonna grab those I'm gonna grab those test files. Oh, I guess we gotta wait until CircuitPy is back though, right? So we are. Got CircuitPy. So now I can just copy these two from the Pico to the Pico system. Now I can unplug the Pico. And I think my TO should have stayed on Pico system. Maybe not though. That doesn't look like it. Yep, I have an ACM1 instead of 0. So we'll just go here. Got these, right? Copy. Copy. Read. Read worked. I'll go right with F's. That we expect to work, but then when we change it to non-Fs, basically we can just go back and forth a couple of times here. Yep, I think we're good. Fs. Okay, we're on Fs right now. I'm gonna go to code. I'm gonna delete this line. Save. Write non-Fs. Write Fs. Write non-Fs. Write Fs. I think we are good. Oh, I hit the end of the history? I didn't know there was a limit. Okay. That seems good. We'll do that. Now uncheck these again. Double check our changes again. I don't know why the size of this is always changing. I feel like I always am dragging it one way or the other. So we got disable as the first call inside right page. Enable as the last call inside right page. Yeah. Disable as the first call inside of erase and right sector. Enable as the last one inside of erase and right sector. And then we took out the disable here. Could maybe go, I don't think there was an empty line here before. I don't remember for certain, but. And nothing before return. We don't need to enable because it happens inside of this function and this function now. Okay. That looks good. We do want to save this since I just edited it by removing that line. Double check, that's looking good now. We only have byte array. Inside of right page, whoops, page and erase right sector. Okay. foamyguy RP2040 NVM. Inside right page, inside erase right sector. Removed them from set bytes. Okay. Push. Should have reran pre-commit maybe. Hopefully that's not going to fail. Nice. Doesn't fail. Okay. And this changes here will show inside a right page now. And right, erase right sector also. Cool. All right. Probably take a while to run the actions. I'm not sure. Yeah, the actions didn't even finish on the old one, but it takes a little while. Okay, yeah, let's run bubbles. Bubbles, this. So we'll grab this. Copy. Here. We're gonna go to CodePy. We don't really need to keep hello world. We're gonna paste this. We gotta make some changes though. We don't need a release. We don't need to set up frame buffer. We can just do board display. I don't know what the rotation of this device is. We'll leave it. Whoop. Leave it default. See what it does. Board. We need to install these. CircuitPython doesn't work on this device yet. Or maybe it's because it's CircuitPy 1? Maybe it's because it's CircuitPy 1. I'm just going to unplug replug. It should come back as CircuitPy without the 1. Well, I'm going to try. Unplug. Oh, hey, our light switched to green there instead of red. Plug it back in. Maybe it needs to shut off. I don't know if it actually needs to shut off or not. Nope, we got CircuitPy. Can we find it now? It does find it now. Okay, so it doesn't like CircuitPy 1. Side circuit. It's the LED shapes was the other one we need. Oh, I didn't save. That's a bummer. Okay, no worries. Copy. Oh, forward. There we go. Need to change anything else? Doesn't look like it. Well, that should be fine. Shapes. So I'll save this now, and it'll crash because we don't have shapes. Oh, also we're probably back to ACM 0. Yeah. Okay, I'm gonna paste this, and then I'm gonna go here, here, get the camera, so we'll see it when it runs. There it goes. Oh, nice. Cool. Do I peel the screen? I'm usually not I'm usually the kind that will leave the screen sticker on until it's like halfway peeled off and got dust underneath it and everything. Nice, so they just kind of flow upwards there. Bubble upwards towards the top. Looks like we got mostly random palette essentially, and it looks like it painted a kind of like a rectangle that represents all of the colors that it's going to use up there on the top. Nice. You know what it reminds me of is like an old school screensaver. Back when it was real common to have a screensaver on your computer. Nowadays, it's usually like it just goes to sleep or whatever. You log in again when you get back. Screensavers aren't that common nowadays, it seems like. But that's what this reminds me of. It's a real neat little demo. Rectangle is all the colors in the palette. Nice. How did you just loop through all of them and make a strip of each? Strip of each color? Yep. This is what's making the rectangle. Yeah, for sure. Thanks for making it and sharing it. Scooch over a little bit here, maybe. Let's walk through the code a little bit. So this is what's making our rectangle. We make a tile grid. We use the same palette. Put it on our group. Make a bubbles group. Looping to 24 times. X gets a random between 128 and 256. Y gets a random between 0 and height. Radius gets a random between 8 and 24. Color is random by choosing random choice out of the palette. Looks like we had a comment one with the stroke on it there. Pinned our circle. And then what is making a move? So we have, this will append the bubbles to the splash. This will append the circles to the bubbles. Herd. Let's see, for shape and group, shape X gets plus equals, so X is always going to go, oh no, because this is negative, sometimes it can go left. Okay, so that's what gives it that little like wiggle going back and forth side to side a little bit. That's a nice effect. Like that. Shape X, if it's less than 9. So it will wrap? Is that what it will do here? I think wrap if it's less than 9, so it'd be like partially off of the left side of the display, depending on what the radius is. Basically, if it touches the left side, then it's going to change the X to be all the way over here, minus 18, so pull it back in a little bit. Don't know if bubbles travel in herds, but it works. Nice. I like it. If it is greater than the display width minus 9, so if it's too close to the right edge, then it gets pushed back over to the left edge. So let's see if we can see one, like this red one here. Yep, it just popped over to here. Let's see if we get another one. Orange, I think, just came from over there. There's a yellow, and there's our yellow over there. So yeah, that's definitely our wrapping across the horizontal sides. Then shape Y goes up Well, it goes down with negative numbers, but that's because origin is up here. So if you want the bubbles to move up, the y is actually getting smaller. So this makes sense. Random between 0 and 5. And then if it's less than -9, so if it's all the way at the top, then just reset it. Shape y goes back down to height +6. So it's the same set of bubbles every time. It's 24 bubbles, and it's the same 24 every time. Once they get to the top, they just respawn back down to the bottom. Well, not respawn, but they change their location back to the bottom. Nice. And then here we have bytes available. So if you write to it, it will stop. If you write to it, it will stop. Is that right? This broke me to REPL. Pretty much anything I press breaks me to REPL. I'm not sure how to send bytes to serial other than the REPL. There must be a way, I'm sure, with TO. I've just never done it. I guess though nothing is ever reading the bytes. If you press a key, it stops. Ah, I see. Pi02 requirement. Okay. Okay. So that's kind of similar to my Pygame display. Has a different loop mechanism as well. It's like while display running, something like that. It listens for the X button on the window. So this makes sense. Okay, it's a Raspberry Pi thing, but it ends up working here as well because all this stuff exists. Which I guess is also probably why as soon as we press, oh yeah, as soon as I press a button, this is working. When I press a button, it's sending the bytes into serial, and then this is noticing that the bytes are there, jumping outside the while loop, and there's nothing after it, so that's why nothing else happens. Exiting. This would print as soon as we press a button. So like I'll press I, and then we got exiting. Nice. Okay, yeah, that makes sense. That's kind of I mean, it sounds like it's required on the Pi, but that's actually kind of a nice idea. I like that, being able to stop as soon as you receive any terminal. That's a neat little trick. Control-C doesn't work. That's why it's necessary. Okay, that makes sense. That does make sense. So we'll run it. Let's leave it back running again. And where does the palette actually come from? So, okay. So you set 5 colors into the palette, and then fancy LED must be... Oh, I'm gonna have to go feed the Cali girl. She's scratching at the door. I'll be back in a minute. Yep, cats definitely take priority, especially when she'll sit at the... We got like a sliding glass door, and she'll sit there and scratch on the glass, and it makes a god-awful squealing sound. Aside from just cats get priority by default, I don't want to listen to that. That's our nice little friendly outdoor kitty. One of these days I should try to set up a cat cam over to there. We just got a big cat tree that we set up downstairs, and that's another thing I want to do, is set up a cat cam pointed at the tree down there, and then I could pull it up in the browser here and we could have it on the stream so we could see the cat when he's playing on his tree. That's the indoor cat though. This one's Callie's the outdoor, friendly outdoor kitty. She lives she hangs out around my house and my neighbor's house most of the day, and then the neighbor brings her into the basement overnights. Hot wheel is a gradient. Palette lookup extracts the colors. Oh, okay. Hot wheel makes a gradient. So we put them all in the list. And then palette lookup. For arranging colors, color equals palette lookup in colors, so number of colors, C is the current one. Okay, so you give it back the list and you give it the C over N colors, current one over total number of them, and then set it color.pack and set it into spectrum, which is the actual palette object. Nice. Okay. That's a neat trick as well. I was not, I don't think I've ever seen that before. I haven't played with LEDs too much. I can see how that would be helpful for LEDs. That's a neat trick though. I didn't know you could do gradients that easily. Honestly, that's actually really cool. Could think of some spots to use that. Lookup takes 0 to 1. Okay, that's why the division then. So we divide the current counting variable by the total number, which means we'll always end up with like between 0 and 1, because it'll be like 0 to 24 or 23, I guess. So those will go over 23 or 4 every time. Or actually, it would not be 24. This would be just 5 for the colors. No, 64. In colors is 64. So we loop 0 to 63, and then we always go 0 to 63 over 64. So we always end up 0 to 1. That makes sense. Yeah, that's a really cool trick, actually. I should, I wonder if there's other neat stuff in this fancy LED. I had no idea it was that easy to make gradients. That's really cool. Huh. Hey, thanks again for sharing this code. This is a really neat example. I definitely learned new tricks from it. And I like it. Like I said, it reminds me of a screensaver. This is like something you could see like when you pause your game, maybe it turns over to this screensaver and just the bubbles float away. You know what would be really fun maybe is on a device with a accelerometer, make it to where if you tilt it a little bit, the bubbles will change directions. They'll like flow upwards or sidewards or whatever, depending on which angle you hold it at. That might be kind of fun too. But even just like this without any input, it's still fun to stare at. I kind of want to run it on like a matrix portal or something too. With LEDs. Neat. All right, let's see. Did anybody mention anything more on this? Not yet. We made our change that Dan wanted. And we're still running actions. And even like the first actions is still not done yet. That'll be a while. All right, I think adding accelerometer would be cool. Letting the bubbles bounce off each other would be fun too. Yeah, so when they like collide, they bounce outwards a little bit. That would be neat as well. Or if you want to get super fancy, maybe they absorb. That's like next level though, because if it absorbs one and gets bigger, then it needs to like probably use vector IO so that it can change the size. Because we just had that discussion the other day about display shapes can't change size. That would be kind of neat though. If you start with 24 and then like whenever two collide, the bigger one absorbs the smaller one and gets a little bit bigger. And so then like eventually you'll end up with one giant bubble because one will absorb everything eventually. But then once you get down to 1, maybe it just resets back to 24. That might be fun too. There's a game like that. I don't know the name of the game. There's an online game like that. How feasible simple 2D physics engines would be. Yeah, I think it's definitely feasible. I haven't done much in the way of physics. I I made one game. I made one game that's sort of physicsy. It's oh, what is the name of that actual game? The Atari game. It's like, I think it's Atari. Atari. Gorilla. Is it just Gorillas? Or QBasic Gorillas? Yeah, this Gorillas gameplay. 2 weeks. I don't want free YouTube. This no, go away. Yeah, this is totally the game. So I made a CircuitPython copy of this game. It's like, if you ever... Scorched Earth is the name of the game that was most similar to this that I played as a kid. Scorched Earth was like tanks. You'd have a tank here, you'd have a tank here, and there's like a whole bunch of different types of weapons that you could buy, like different bullets basically that do different things. Like some of them explode small, some of them explode big, some of them shoot like lava, some of them like dig up the dirt, all kinds of different ones. But this is kind of the same engine. It's like, you choose the angle and you choose the power, and then in this one it's gorillas. The gorillas throw the banana, and the goal is to try to hit the other gorilla over there. So you can see that one didn't have nearly enough power, and the angle wasn't steep enough probably as well. I made this, and I did not. I don't think I did. I'm not actually sure how I got the, I probably would have to go get the Pygamer. I don't know if I saved a copy on my computer. I should come back, though, and save a copy on my computer. Maybe we'll go... Maybe I'll do a quick search. What if I go here... Crypto algorithms. Yeah, we got no gorillas. Yeah, I think that I got a copy of that on my Pygamer, but I don't have it anywhere else. I should copy it off of there, though, so it doesn't get lost. I actually started making it 2-player, and it communicates over LoRa. So the idea would be you'd have 2 different people, each with their own Pygamer, with a little LoRa feather wing plugged into the back. They would load up the game, they would get paired together, and then when one person throws the banana on their side, it sends a message over LoRa, the other one receives it, and then, you know, draws the banana traveling the same path. And that way you can play back and forth, and it just, each time you throw the banana, it sends the, whatever it needs across LoRa. I need to finish that up. I think like the core... like proof of concept worked, but I never did flesh it out all the way to the rest of the game. I had the game working in like 1-player mode. You could just play on one Pygamer, and I think I started the LoRa communication, but ended up stopping partway through. Maybe that's something I'll work on one of these days on stream. It sounds like a fun project. I can't remember where I got the, I think I just found something online, the algorithm that does the arc though, which is like, it's kind of gravity-like. I don't know if it's exact Earth gravity or whatever, but it seemed to calculate pretty well on the Pygamer. That's a SAMD51, so it's also a pretty beefy microcontroller, but it didn't seem to have any trouble with it, as I recall. Yeah. Yeah, Basic. Basic was my first ever programming, was in Basic. I didn't do a whole lot of it, but that was like the very first programming I ever did. Yeah, floating point math could be an issue. I could see that. Oh, nice. Made some clones of this game? Yeah, I should. It's been a while since I've thought about that project. I should definitely. Thinking about it and talking about it now, though, gets me kind of back in the mindset of it. I'm excited about it again. I think it'll be fun to go finish that up on stream, get the LoRa working. I think that'd be a good idea for 1 week. I think I'm probably gonna wrap it up pretty much here, though. So I got a lot done today. Again, I'm super excited about the fact that I actually managed to figure out how to fix this with obviously a lot of help from Scott. Also last week, for folks that didn't watch the stream, I got a lot of help from Deshipu and AT Maker's Bill for being able to do the GDB debugging to find the stack trace, which is what I showed to Scott, which is how he knew where to point me. So thank you to those folks, Deshipu, AT Maker's Bill, and Scott. Without their help, I would not have been able to fix this, but I am super stoked that I managed to get a solution to this, and we'll get it merged pretty soon, I assume, and then we will all be able to use NVM storage on RP2040 devices, which is awesome. Thank you to Dexter for sharing this Bubbles game. Not game, but little graphics demo here. This is really sweet. I like this quite a bit. And yeah, thanks Squid for tuning in. And for folks that might not know, this is kind of like my normal time to stream. So I started at 10 a.m. on Saturday mornings, which is just under 3 hours ago. It's about 2 hours and 50 minutes ago. So whatever time zone you're in, whatever time it was 2 hours and 50 minutes ago, every Saturday I stream here. So if you're interested in this kind of stuff and you want to catch me next time, that's where I will be. I should be streaming next Saturday as far as I know. So yeah, 10 a.m. Central Time, or 2 hours 50 minutes ago from right now if you're watching this live. So thanks everybody. I hope everyone has a good weekend, and I will catch you next time. See ya.